Pause the video and complete the quiz. Pause the video to check and correct your answers. Today's lesson will be on speed, distance and time, and this is the first lesson in the new topic of motion. Earlier in the year we studied a topic all about energy, and in that topic we firstly looked at different types of energy. We looked at light energy, thermal or heat energy, electrical energy, gravitational potential energy, sound energy, chemical energy, elastic potential energy, and kinetic energy. And we discussed the idea that when anything changes, there has been a transfer in energy. For example, turning a light bulb on, there has been a transfer of energy from an electrical store into light and thermal. And this brings us on to look at the conservation of energy law. And that states that energy can be transferred from different stores, but never created and never destroyed. So energy is never just made, and it's never destroyed or gotten rid of. It's always transferred from one thing to another. We spent a bit of time looking just at kinetic energy. And kinetic energy is the energy associated with anything that's moving. And there were two things that affected the kinetic energy that an object has. One of those things was the object's mass, and that is how many particles the object has. The other thing that affected the amount of kinetic energy that an object has is the speed that that object is moving at. So here we have two cheetahs and they have the same mass, but they are moving at different speeds. The one on the left is moving fast and the one on the right is walking quite slowly. And so the one on the left, the one that's going faster, will have a larger store of kinetic energy. So in this lesson, we're going to focus on speed, what it actually is, and how to calculate it. So here we have two people and they run the same distance, but they take different time to do it. The first person takes 10 seconds, the second person takes 30 seconds. Which is faster? Well, the person at the top does it in a shorter time and therefore they must be travelling faster. In this case, we have both people running for 20 seconds. One of them covers a shorter distance on top, one of them covers a larger distance on the bottom. Given that they both run for the same amount of time, the bottom person is running faster because they cover more distance. I would just like you to pause this video now and think about any units for speed that you know. You might know the speed unit that people use when they drive in cars, for example. Pause and just have a little think about units that you know. So, some units that you might have got. You might have got miles per hour. You might have got kilometres per hour. And you might have got meters per second. Now, what these all have in common is some unit of distance, so miles, kilometres or meters, per some unit of time, hours or seconds. And this is really key to understanding speed. Let's look at some examples of some speeds. So grass grows 3 centimetres every week. Now we can rephrase that to say grass goes 3 centimetres per week. They mean the same thing. And I can even shorten this again. Grass grows 3 centimetres per week. That / stands for per. So all of those three statements mean exactly the same thing. Let's look at another one. Tectonic plates move 10 centimetres every year. Tectonic plates move 10 centimetres per year. Tectonic plates move 10 centimetres per year. That forward slash just stands for per, and that means the same as every. When rockets launch, they travel 8 kilometres every second. This is the same as saying when rockets launch, they travel 8 kilometres per second. And again, when rockets launch, they travel 8 kilometres per second. That forward slash means the same thing. People walk 1.5 metres every second. People walk 1.5 metres per second. People walk 1.5 metres per second. So whenever you see that forward slash between a distance and a time unit, you know that it stands for per or every. Here are some examples of some interesting speeds. And what I'd like you to do is pause this video and say 2 sentences for a few of these examples. For example, a car travels at 13 metres every second. A car travels at 13 metres per second. So I'd like you to say both of those sentences for a few of examples that you choose. Here are some more interesting speeds. The average walking speed is 1.5 metres every second. The average running speed for a human is 3 metres every second. The average cycling speed is 6 metres every second. The speed of sound travels at 330 metres every second. Light travels at 300 million metres every second. And that can also be written as 3 times 10 to the 8 metres every second. I'd like you to pause this video and say all of those speeds just like I've done. Now I'd like you to have a go at writing them down from memory. Pause this video and have a go. Okay, check your answers with the ones on the screen now. So going back to the units that we have for speed, we have miles per hour, kilometres per hour, metres per second, and the thing that they have in common is that there is a unit for distance per or every or divided by a unit for speed. In physics, we usually use metres per second, and so any time that you're asked to calculate a speed, you will be expected to find the answer in metres per second, or a number of metres every second. But it's always a distance per time, or a distance every time. This brings me on to the equation to calculate speed. Speed is equal to the distance travelled divided by the time taken for that distance to be travelled. So the unit of speed is metres per second, the unit of distance is metres, and the unit of time is seconds. I would like you to say this equation out loud. Don't write anything yet. Pause this video and say speed equals distance divided by time. Now I would like you to pause this video and write down the equation from memory. Make sure you've written down the equation correctly and included the units. I'm going to show you a problem where we are asked to find speed, and I'm going to show you how to solve it. So a person runs 30 metres in 10 seconds. Calculate their speed. Well, the first thing to do is to write down what we've been told. 30 metres is a distance, so I can write D for distance is 30 metres. 10 seconds is a time, so I can write T for time is 10 seconds. And we've been asked to find speed. So S for speed is question mark at the moment, we don't know that. I'm going to draw a line and I'm going to write out the equation that speed is equal to distance divided by time. Now I can put in the numbers that I know. I don't know speed yet, so S is equal to D. Now distance is 30 metres, divided by time, which is 10 seconds. Speed 30 divided by 10 is 3, and the unit is metres per second. Let's do another example. A person sprints 45 metres in 5 seconds. Calculate their speed. So distance here is 45 metres, so D is 45 metres. We've been given a time of 5 seconds, so T for time is 5 seconds. Calculate speed. S equals question mark. The equation is that speed is equal to distance divided by time. Speed is equal to 45 divided by 5. So the speed is 9 metres per second. And this means that that person is travelling 9 metres every second, which is incredibly fast. I would now like you to have a go at the worksheet. Specifically, have a go at section 1, and when you've done those questions, come back to this video and watch the next bit of help. Okay, let's have a look at a slightly different question. A cat runs at 5 metres per second for 4 seconds. How far does the cat travel? So this says that the cat is running at a speed of 5 metres every second, and the cat does this for 4 seconds. So I'm going to show you 2 ways of working it out, and we'll agree at the end that using the equation is the easiest. The first way though that we could do this is we could say, okay, 5 metres every second. So after 1 second, the cat will have run 5 metres. After 2 seconds, if he's running 5 metres every second, the total distance will be 10 metres. After 3 seconds, the cat will have run 15 metres. And after 4 seconds, the cat will have run 20 metres. So we could do this every time. We could say, okay, they run 5 metres every second for 4 seconds, so let's just count up. But this becomes difficult if you're given a large time. It would take a long time for you to calculate that if you had a large time given to you. So what we do is we use the same equation that we had before. I'll start by writing out what I've been told. So this time I've been told a speed, and that's 5 metres per second. I've been told a time up here, 4 seconds. And then I've been asked to find how far the cat travels, and that's a distance. So D is question mark in this case. The equation is speed equals distance divided by time. In this case, the speed is 5, so 5 is equal to some distance that we don't know yet, divided by the time, which is 4 seconds. Now the way we rearrange this to solve for distance up here is we do 5 times 4, and that is going to equal our distance. So the distance in this case is 20 metres. So I get the same answer that I got over here, but this way is much quicker if you have a large time given to you. So this is the way that I expect you to do your calculations. Okay, let's have a look at another question. A dog runs at 6 metres per second and goes 30 metres. How long does this take? So, using our equation, we have been given a speed, so s is 6 metres per second. We've been given a distance of 30 metres, and we've been asked how long does this take, which means we need to find time. So the equation, speed equals distance divided by time. Speed in this case is 6 metres per second, and that's equal to a distance of 30 metres divided by some time. Now the way we do this one is I do 30 divided by 6, and that's going to give me the time. 30 divided by 6 is 5, so the time is 5 seconds. I would now like you to have a go at more questions on the worksheet and check your answers as you go. You must show your workings out for every question.